So today I wanted to cover local models, and this is kind of in celebration of OpenAI finally deciding to release an open source model. When they announced that they were going to do an open source model right after DeepSeek released, I didn't actually think it was real. I thought it was Sam Altman trying to, keep up with the neighbors and doing just announcing it and never expected to see it. So since we got it and it seems to be pretty good, I've played with it to a certain extent. I did have some problems running tools with it, which was a problem that turned out to just resolve itself. So we'll go through it. So the idea with local models, okay? Local models, if you're familiar with using models in the cloud, if you go to chatgpt.com or claude.com or wherever you're going, you're used to running the models on the cloud, which means you're actually running it on the equipment of the foundational model provider. So you're running it on ChatGPT's equipment, which they have billions of dollars. So they are running much bigger models and much more capable models than you could possibly run at home. But local models have their use cases, and with the fact that a lot of companies do not want to send their proprietary information to the cloud for processing, especially after OpenAI got sued by the New York Times and they have to turn over their prompts and their responses to the court. A lot of people aren't all that happy about the idea of sending your prompts to the cloud models. The other thing is the cloud models tend to get really expensive really fast. If you're using the Claude API for writing code and you don't have the max plan, you can run up your pay per use really quickly. So local models actually run entirely on your equipment, and they use programs like Olama, which was really the first one. Now, Olama, I really liked it first, but it has a tendency to crash my Mac, so I started going and I switched over to LM Studio. And one of the things I really like about LM Studio is it's a lot easier for developers. So if you're a developer and you want to use MCP tools or you want to do a pipeline, it's a lot easier to do that with LM Studio. Okay, so let me get back to my slideshow because my cat is actually hitting keys, so we'll be moving that keyboard. So your local model is going to run entirely on your local computer. And that is compared to models that run in the cloud like ChatGPT, Claude, Gemini, and Grok. Now, when you are running local models, you have some benefits. Now, the biggest benefit to me is that all your data is staying locally on your machine. There's no third-party exposure. Now, if you're doing things like writing code with them, there's no cost per token or no subscription fees. So once you've got your hardware and you've got it to run, you can run everything local. Now, latency is also a thing, but I have found that as the cloud models get better and better, you can't really call this a benefit of the local models because the local models are going to be slower, especially if you're pushing the limits of your hardware. But you do get near instant response. You've got no dependency of the internet, and you're not subject to Claude going down occasionally, ChatGPT going crazy occasionally. You're not constrained by that. So the other thing is you have full choice you have your control of the model. You have your full choice. You can choose which model, which version, and which model you want to tune. Now, the whole thing with ChatGPT 5 is actually making this more important because one of the things that ChatGPT is not doing is being backward compatible. So one of the things that OpenAI announced is that when ChatGPT is out and stable, it's going to be the only model. You're not going to have access to 3.5 or 4 or 4.1 or whatever you're used to using. So if you build an application, let's say you build a chatbot, and that chatbot is working really, really well, and it's working really well with ChatGPT 3.5, you got it exactly the way you want it, and then all of a sudden OpenAI says, no, now you're using 5. Well, just because a model is bigger and just because a model knows better does not necessarily mean that it's better for your use case. So if you're going to run an application and you need it to work day in, day out for years, you're better off with a local model because you can choose to use the old version of the model and you can use it as long as you want to. As soon as you've got it, it's in your inventory and you can use it. The other thing that is great is, you've got offline use. It works without network access. Now, this is not as big of a flex as you kind of think it's going to be, because in the end, you still want your model to go out and be able to search the web, be
Yeah.
able to get resources from other locations. So yes, it does work without network access, but that's not necessarily, as big of a deal as you can make it out to be. Now, the other thing is customization. Now, because you're running a smaller model and you're running a local model, you can customize it. And there's definitely some benefits to customization. So now the drawbacks include the hardware requirements. Now, I am running on a Mac M1, a MacBook Pro M1 with 32 gig of RAM. Now, the difference between the M1 and the M4 when it comes to
Okay.
Apple Silicon is like night and day. So I have another box over here, which is my Mac M4 Mini. And this has 24 gig of RAM. It was only about 1,500 US dollars, and it runs about 8 times faster than my M1 MacBook Pro. So it really does run a lot faster. It just doesn't have as much memory, and I always have to jump through hoops in order to get it up and running. So I still am going to use my MacBook Pro. Now, the in addition to the hardware requirements, you also have the small model size. So when you're running even a 20 billion parameter model is nothing compared to a 1.7 trillion parameter model. So you are going to suffer from the capabilities of the small model sizes. Now, with the new reasoning models and the fact that the models can run tools, that gap is getting smaller and smaller. Even a trillion parameter plus model is not going to perform that much better than a small model if that small model has tool access. Now, the cloud models also provide extra benefits, and you don't realize everything that ChatGPT does for you until you run it locally. Because ChatGPT 4 is basically an AI agent wrapped around an LLM. When you go out and ask it relevant current events, it's running local agents to go out to the web to surf. You can even see in ChatGPT where it says checking the web. So there's a lot of things that the cloud model providers are adding for you that you are not getting from the local models. And then another drawback is they're definitely slower. There's really no arguing that a local model is going to be as fast as something that has multiple billion dollars worth of hardware behind it. You can't make that argument, but that is a trade-off that is usually worth having. The next problem, now this is the problem I see the most, especially trying to use local models if you're using it for coding, is the size of the context window. Now, one of the beautiful things about the new GPT OSS is I think it's 156K context window, or it might be actually closer to 200K context window. So you have a decent sized context window. But the thing you have to realize about your context window is it has to fit in your memory. So if you've got it where it just barely fits in your memory the way you've got it, that is usually just barely fitting with a much smaller context window. So I tried to bump my context window up to, I think it was 10K today, and it decided that it was not having any of that. So that actually caused me to have to reboot my computer earlier. So the context window size is a problem, and tool use is complex. You have to understand how MCP servers work in order to effectively use MCP. So let me make sure this is the right. Okay. So there are times that local models are definitely not going to be right for you. So if you need the most capable model, you need nuance. Now, nuance is a big deal. So a lot of times when you're doing something with a reasoning model, those big reasoning models are really good at just figuring things out and understanding subtle differences between things. You do not get that with the local models, even the biggest of the local models. Now, I have not been able to run the 120 billion parameter GPT OSS. But look, 120 billion parameters still is not a trillion parameters. So I doubt that you're going to get the nuance from the local models, even when they're a little bit bigger. And if you need a ton of built-in knowledge, these local models just aren't going to have them. Now, sometimes the fact that they don't have the built-in knowledge is a benefit for you because what you end up with is the larger models have a tendency to be more opinionated. So Gemini is extremely opinionated, and it's going, if it knows something, you are not going to be able to override it with like some retrieval augmented generation or some alternative facts. So if you need the more capable models and you need the tools that they automatically provide, again, when you start running local models, that is when you're going to figure out all the things that they don't do. And that's actually when you're going to figure out all the things that ChatGPT does for you automatically, just because they've decided they want to be nice. So local models come in formats that are different than you would be running it if you were running it in your data center. So the most common format you're going to download, and this is important if you're going to Hugging Face to get your models. If you're going to olama.com to get your models, it's going to be in GGUF format because that's what Olama supports. If you go to LM Studio, it's going to be in either WLX, which is their format, or it's going to be in GGUF. So LM Studio will run them both. And then you've got some some less common ones if you're actually running the model yourself. So if you're writing your own code in Python, you can use PTH and BIN, which are PyTorch formats for running your own model. And then there's something called safe tensors that you can run. So there's a couple of things you have to look at when you're running local models. The first of which is the format, the second of which is the quantization. Now, quantization is basically the rounding of real numbers. So when you first train a model, it's gonna get trained in either 32-bit or 16-bit, usually in 32-bit. 32-bit has a lot of precision after the decimal point. So think of weights and biases as being a number between 0 and 1. And how precise that number is based on how many points you can get after the decimal point. So if you're using 32-bit floating point, you can get a lot of numbers after the decimal point. And that's very, very precise. But it takes up a lot of memory. So in this case, it's going to take 32 bits for every weight and every bias. So every parameter. So if you are using, let's say, a 20 billion parameter model, if you are going at 32-bit precision, it's going to require 80 gigabytes just to load. So what you do in these local models is they quantize them down into lower precision. So you could go with a 16-bit, an 8-bit, and a 4-bit. And in almost every case, you're going to find that these local models are running at 4-bit. And what happens when they're running at a lower precision, it means you're more subject to hallucination for one, because it's doing the math, and the rounding of the math can get off, and you lose the nuance. So you lose what you get by having more precision. So the goal of quantization is to reduce your file size and memory usage so that larger models can run on smaller hardware. So that's a good goal to have, being able to run as big a model on as small hardware as possible, but it produces a trade-off. So there may be situations where, let's say you have 32 gig of RAM, and you're better off running a 1.5 billion parameter model at full quantization or no quantization than you are running a 20 billion parameter model at 4-bit. So this is where testing it for your use case comes in. Now, mostly when I'm talking about using local models, I'm talking about using them in applications, because personally, I don't get the answers I'm looking for from the local models in a time that I'm looking to get them. So for example, the first query I gave to GPT OSS 20 billion parameter was, if it's 1 p.m. in Central European time, what time is it in Chicago? And it struggled with that answer. And the reason it struggled with that answer is it did not know if it was daylight savings time or standard time in Chicago. So it didn't know if it was a 7 hour difference or a 6 hour difference. And just the process of it thinking about it meant that that answer took probably 3 minutes to get. And it
Yeah.
had to add another question, which is what day is it? Because when I was running it, it didn't have any access to tool use. So it couldn't go out and run a little Python script to go out and find out what day it was to know if it was 6 or 7 hours different. So when I'm talking about tool use, I'm really talking about using it for applications, applications that you don't want to get hammered by expensive API usage because you're still in a lot of cases, and I'd say in almost most cases, the free version of ChatGPT is going to give you better responses than, you know, probably one of your best local models. But when it comes to applications where let's say you're running a call center or you're doing a ton of transformations on data, maybe you're doing vector embeddings, that is when a local model is definitely going to come in because you're getting use out of it. You're getting the benefits of it not costing a fortune to run. So if we look at quantization, we have a whole bunch of different types of quantization. So full precision at FP32 is something you're almost never going to see because unless you're running your own data center with NVIDIA GPUs, even the smallest model isn't going to fit at FP32. Now they say that FP16 and BF16 have nearly the same accuracy, and I do believe that because there is a point at which the precision isn't going to matter that much if you don't have as many parameters. So if you have a trillion parameters, then you're going to need the nuance of FP32. But if you're looking at something like even 120 billion parameters, you can probably get away with FP16. Now, then you start getting to the smaller ones, which is you get to int8, which is it says it's a good balance of size and accuracy, but it's much faster. And that is actually another thing you have to realize when you're running local models. The higher the number, so if you're FP32, the math that it's running is more complicated. It's going to use more resources and it's going to get considerably slower. So what you're going to be used to is 4-bit quantization, or um, if you're just playing around, you can do 2-bit quantization, and it is pretty bad. So that's really not a direction you go. Now, there is another option called mixed quantization, and that is where different layers are quantized at different precision levels. So instead of using like an FP4 for the entire model, you might use an FP16 at some of the top layers or the bottom layers, or there's a whole different strategy. And there are a lot of different models out on Hugging Face that have been trained experimenting with different mixed quantization. And so mixed quantization sometimes can get you really good accuracy and performance, but it doesn't actually hurt the model much. So parts of the model are getting higher precision, and the less important parts of the model are getting less quantization. Now, when you're choosing a local model, you've got a couple of main choices you need to make. And the first one is reasoning models versus non-reasoning models. Now, reasoning models are really the thing now, but they are slow. So you have to realize that, just asking the question of what time is it in Chicago when it's 1 p.m. Central European time, that takes several minutes reasoning. Now, the reality, though, is it's going to get you the right answer. Whereas the non-reasoning models are optimized for fast and direct responses. If I was using a non-reasoning model, it probably would have returned in just a couple seconds and said, it's 6 or 7 hours, depending on what day of the year it is. And it would have just come back immediately. So you want to choose your model based on what you're doing. So if you're writing a paper and you've already got all the content for the paper, so you don't need to go doing out and doing searches, a non-reasoning model is going to return just as good of results as a reasoning model. But if you're trying to write code, then, or you've got multi-complex, multi-step thinking tasks, you're going to need to use a reasoning model. Now, the common reasoning models are DeepSeek R1. I've never heard of OpenHermes. I just copy and pasted that. Mistral I've used, Qwen 2.5 I've used, and then obviously ChatGPT or GPT OSS is a reasoning model. And when you start running it, you definitely can see that it's a reasoning model. Now, the next important thing when you're selecting a model is can it use tools? And I'm going to go to, real quick, I'm going to go to llama.com. So when you go to llama.com to find models, and you can do the same thing at OpenLLM, when you go into models, you do want to use the models that support tools. So tools like GPT OSS, DeepSeek R1, Qwen 3, Llama 3.1, they all support tools. Now, think of tools like being able to take a test using a calculator. I remember when I was in high school, I was learning to do square root, and my father was telling me how you're not going to have a calculator. You have to learn how to do it because you have to know how to do it because you're not going to have a calculator. Well, this is like giving ChatGPT a calculator. And it does it by calling something called Model Context Protocol. And the model is actually trained to go out to MCP, get the tools and how the tools work, and then structure a JSON call to actually call the tools. So MCP is a standard that lets your AI models call external tools. Now, it is really critical with these small models because the small models don't know very much. They weren't trained with a lot of recent information. And if you look at, ChatGPT is or OpenAI is really good at hyping things. And one of the things that they hyped was that their 20 billion parameter OSS model is almost as good as O3 as long as it has tool use because it's optimized to actually go out and write Python code. So for instance, if it needs to know what day of the year it is, uh, GPT OSS will write a quick little Python script that will return what day it is. And basically, just giving OSS Python access completely changes the precision and the quality of the model. So in almost every case, you're definitely going to want to make sure that the models you choose can use tools. Now, tools are crazy important because of some of the examples that you can do with it. So the first thing is database queries. So you can actually have your tool go out to a local SQL database and fetch records for a report. And if you're using local models for building applications, which is what I highly recommend you use them for, this is something that you're going to want to do. So the MCP, the uh, your prompt says, I need this information. The MCP server says, oh, I know where that is. That's in the SQL database. It creates an SQL statement, and then it calls the SQL database and it fetches the records. Another use is web browsing. Now, this is where ChatGPT shines because so many things, and it's actually also where Gemini shines. So many times when you go and ask it, hey, I'm trying to do this in LM Studio. Well, what it's basically doing is it's going to the LM Studio website and reading the web pages and then summarizing it for you. So web browsing is huge. Anytime you need to access the file system, that is another time you're going to be using MCP tools. And then anytime you want to execute custom scripts, and this is kind of where the LLM itself is really good because ChatGPT 5 for sure, Claude for sure, and most of the local models are really good at writing Python. They write Python pretty much as good as any human, and they can do write their own scripts to get the information that they need, and they're pretty much smart enough to be able to do that. So in practice, the way this works is you go into LM Studio or you go into your API or however you do it, you put in a user prompt. So you might say, summarize all new orders for the week. The model then decides that it needs to be able to get all the new orders from the week because all the new orders for the week are not trained in the model. So the model says, I need to go get fresh data. And it has a list of all of the tools that it has access to. And it says, call the order API tool. It goes out, runs a SQL query on the local database, and then it basically takes that information, runs a SQL query, takes the result, pushes it back into the model, and then the model generates a natural language summarization using the retrieved data. So this is crazy powerful, and local models are getting really, really powerful. Now, I'm kind of with ChatGPT 20 billion running as well as it does on only 14 gig of RAM. I think that the local models are really getting to the point where in a ton of different use cases, they're really going to be models that you can get away with using. Now, the other thing that the one thing that used to be the selling point for local models when they weren't as capable was that you could, excuse me, make them more capable by supervised fine tuning. And supervised fine tuning has this mystique to it, like it's this super highly technical process that you have to have years of Python experience to do. That is absolutely incorrect. You can basically be a script kiddie, copy and paste some code, go to Hugging Face, and supervise fine tune all day long. So, supervised fine tuning is the process of training an existing AI model on labeled data set. So you basically get the data. Now, with supervised fine tuning, the data is usually harder to get than the tuning itself. So, for instance, let's say you've got a chatbot and the chatbot is working for Best Buy and the chatbot wants to answer questions about your orders. Well, you're running a small local large language model. So what you're going to do is you're going to pass in a set of example conversations. You're going to say, this was a conversation that we had. This is what good output looks like. And as the model is trained, it gets better and better. So basically, what you're doing, and the reason it's called supervised, is it's guided by correct answers. So it says the customer asked me this, I responded with this, and you respond with the correct answers. You don't try to outsmart it by having it try to figure out what a good answer and a bad answer is. You just give it correct answers. And then this is going to help the model specialize into a specific domain, follow instructions, or improve the accuracy. Now, so if you go to ChatGPT, a lot of times you start your prompt with, you are a helpful assistant, or you are a medical expert, or you are an advanced reasoning coach, or whatever it is. Those huge models have the nuance, they have the precision, and they have the number of parameters that they can return the output like a helpful assistant, like a medical assistant, like a dental assistant, like a lawyer. Those big models are big enough that they have the nuance, but the local models are not. They are going to give you pretty much whatever their mood is, that's how they're going to respond. So by fine tuning the model, you are going to teach it to respond exactly the way you want to. So supervised fine tuning is very good for helping the model specialize like being a medical assistant. And it's really, it's done by just feeding the model thousands of, in the case of medical, you just feed it thousands of medical Q&A pairs. So it really becomes an expert as a virtual doctor. Now, there is some different types of supervised fine tuning. The one that almost everybody uses is called parameter efficient fine tuning. And in that case, you're not actually changing the model itself. You're adding an additional layer to the model with your supervised with your supervised training data. So there are different ways to do it, and the different ways you do the fine tuning depends on how much hardware you need to do it. But for the most part, let's say you've got your AI agent business, or you're selling tools, or you're doing whatever it is you're doing with AI. Almost everything you're going to need to do with supervised fine tuning, you can do it on Google Colab or on Hugging Face. It's going to be pretty rare that you're going to be doing enough supervised fine tuning that you're going to need to go out and buy a room full of NVIDIA GPUs. For $20 a month with Google Colab, you have, I think it's access to A100s, and that is definitely enough to do any supervised fine tuning that you need to do. The only problem with supervised fine tuning is there's a lot of trial and error to it. So you can do a supervised fine tuning, come back and just realize it was a train wreck and you need to do it again. And it could be because you don't have your data sets right. There is some trial and error to it, but it's not as big of a deal as people make it out to be. Now, the common problems you run into with local models when you don't have supervised fine tuning is you get very generic responses. Sometimes very generic responses are perfectly fine. But in a lot of cases, you want your responses to be domain specific. So it also struggles with industry specific terminology. So if it's got, if you've got words that you're only using in law or words that you're only using in medicine, doing this supervised fine tuning makes sure that those words become a priority in the output. The other problem without supervised fine tuning is it may not follow a fixed style. And in a lot of cases, especially let's say you're doing a chatbot, you don't want a chatbot that's going to act different every time somebody talks to it, especially if you're using it to generate a realistic conversation. You want it to be consistent. And that's one of the problems with local models without supervised fine tuning is you can't just put something in your prompt to make it consistent. So another issue with local models without supervised fine tuning is it is much more likely to produce incorrect or fabricated details if it's a very specialized task. And the smaller models are definitely going to underperform compared to the cloud models without customization. So personally, if I was doing, let's say I was doing an automation and I was doing a chatbot where I wanted it to um, answer consistently, the first thing I would look at is can I afford the token costs using one of the cloud models? And can I get it where I need it to be by prompting? If I can't get it to be where I need it to be by prompting, or I need it to, I'm just going to use it so much that I really can't afford the token costs, that's when I'm going to go to a local model and I'm going to add supervised fine tuning into the mix. So the reasons for using supervised fine tuning is you're basically adapting a very small general purpose LLM to your industry or business needs. It's going to enhance the instruction following. It's going to format the output better. In a lot of cases, that's the only thing you're going to do with supervised fine tuning. So you can teach a model to always return JSON objects or always return XML. If you've got a format that you want to be very specific, you can make it happen with supervised fine tuning. And supervised fine tuning is a way to make the smaller, cheaper model perform like the big model. Now, the other thing you're going to do almost religiously with local models is retrieval augmented generation. And retrieval augmented generation and MCP tools are the definition or the line between the two are really starting to blur. So a year ago, before MCP, you would have called everything retrieval augmented generation that uh, consists of going out, getting information, putting it in the prompt when you send the prompt to the LLM. But since MCP tools have happened, most MCP tools do some sort of retrieval augmented generation. Now, they don't necessarily do it before calling the LLM. So if you're looking at a workflow, let's look at a workflow where a prompt comes in, you want to give the LLM some hints then you want a single pass through. So it's, let's say it's not a reasoning model. You just want a one-shot prompting. So you're going to go out, you're going to go maybe to a vector database, you're going to query some examples or some data, you're going to include that in your prompt, send the prompt to the model, and it's going to return the results. That's traditional retrieval augmented generation. Retrieval augmented generation with tools is where the tool halfway through the process determines it needs more information. But it is still augmenting what the LLM is doing by retrieving extra information. So, a very standard workflow, especially if you need information that is new and relevant or very specific to your organization. So, the biggest use case for retrieval augmented generation is going to be using companies' proprietary information in the prompt. So that one prompt that we did earlier, which was summarize first quarter sales for our company, well, that's going to require you to go out, get the information, put the information in the prompt, and then summarize it. So in the case of RAG, it is retrieving the information before answering. And in the case of tools, it is the model that is determining that you need to go out and get more information. So in RAG, the retrieved text is injected into the model's context, so it can answer with up-to-date specific information. So again, this, I believe, is one of the biggest areas that there is money to be made in corporate, in just the corporate environment throughout the world. Because and asking random questions of an LLM is great, but the ability, let's say you're at McDonald's Corporation and you want to run a report about your sales figures for 2022, the only place you're going to get that information is outside of the model because it's not trained into the model. So it is really important for local models because the local models are very limited in the amount of training data that they have. So they really are not going to know recent or private information. So retrieval augmented generation is going to give them access to your current, your proprietary, or your regulated data without retraining. So it also, with local models, it's keeping all of your data on premise. So if you've got something that you don't want sent to ChatGPT, but it's local proprietary information that you're pulling out of a database, this is the way to do it. So again, the benefits are privacy. It's always up to date. You've got your domain expertise without SFT. Now that's an interesting statement because the way I see it is you should try to do everything without supervised fine tuning. If you can get it to work without SFT, do it. And then if you start with retrieval augmented generation, it's possible retrieval augmented generation is going to be enough unless you've got specific formats. And then when you determine that you can't do it with retrieval augmented generation, add supervised fine tuning into the mix. Other thing about it for local AI is it's very hardware friendly. You can basically use much more smaller amounts of data and you don't have to fine tune nearly as much. So an example stack for retrieval augmented generation would be something like LM Studio, a vector database like ChromaDB or Pinecone, an embedding model, and then an orchestration framework like LangChain or Llama Index. So let's talk about getting started because that's where I want to get into this and just kind of show you how we do it. In my case, I'm using a Mac M series. The thing about the M series is that it has the unified memory. So when an M series Mac says it's got 32 gig of RAM, that RAM can either be used for GPU, CPU, or both. So it is an easy, inexpensive way to get started with this. The other way is to have a dedicated GPU with something like a gaming PC. Now, GPUs with a lot of memory get expensive, so even a GPU with a 24 gig of RAM can cost several thousand US dollars. So having a dedicated GPU does kind of get expensive. So the two that I like are Llama and LM Studio But Olama seems to have some memory issues because if I've got Photoshop open and I've got Olama running, I'm basically rebooting my Mac. LM Studio is way easier for devs, and that's the one that I'm going to recommend. That's the one I'm going to demo. And then you want to start with some small models. And then you want to enable the tools and you want to use the reasoning models. So let me jump over to LM Studio. So if you're unaware, this is usually not what it looks like. This is my models in LM Studio. So LM Studio is an interesting tool. It reminds me very much of working in VS Code. So you've got these different modes that you operate in. Now, in this case, I am actually running the two that I downloaded is I downloaded GPT OSS 20 billion and I downloaded Quen 3 billion. Over here in the settings, you see I got this little red dot. It's because I've overridden some of the settings. And in this case, what I did is I made the context size bigger. The context length, I think it started like 3,600 or something, and I pushed it way up. Now you can kind of see as it gets bigger and bigger, it knows that it's pushing the limits of my memory. But if you're used to writing code with artificial intelligence, you're used to filling up a 200K context window in like 15 minutes. And if you monitor the context window on this, you will notice how fast you're going to fill it up. So, for instance, let me come over here.
Recording in progress.
I'm going to come over here with Quen. So I'm going to go back to my chats. Actually, I'm going to go back to my chats and I am going to create a new chat. And in this case, I am using, I gotta get this thing out of my way. I believe I am using the Quen. That was the last one that I was using. A lot of times I'm not 100% sure what I'm doing here. So I've got my chat. Make sure that I've loaded this model. Okay, so I'm actually running, yes, I am running the Quen. So I'm going to come back over here and I'm just going to do something simple. And actually, I asked ChatGPT, um, too many things in the way. I'm going to go back to ChatGPT and say, um, give me, and now this is ChatGPT 5, by the way, which I've found to be fairly interesting so far. Give me a sample prompt to test my local model with tools. Okay, so ChatGPT is going to give me a clean prompt. You're connected to two tools. I'm actually not. Um, Maybe I'll just go back here and I'm going to say, the first question I'm going to say, so I know here that I have turned on the Hugging Face MCP server. So I am going to say, what Hugging Face tools do you have access to? Okay, so it is now, I can use the following Hugging Face specific tools, all under the functions namespace. So one of the ones is who am I? So I can actually say, maybe I can do research papers. So there's a research paper search. And so this is where I'm actually running a local model. I'm running a pretty darn small local model. I'm running a 2 billion parameter model. And I'm actually able to get, oh, actually, no, I'm not. I'm actually running Open AI GPT OSS 20 billion. So let's give this one a little test. So let's say, um, who am I logged into Hugging Face as? So I ask it a simple question, And notice it's not as fast as ChatGPT. We can pretend that it is going to be as fast as GPT-5, but it's really not. So it's thought for 0 seconds. It knows that it needs to do Hugging Face, who am I? And it is says you're logged into Hugging Face as e-honors. So it was able to go out and get that information. So now let me just do some basic prompting. Write me a recipe for chocolate cake, knowing that it needs to be gluten free. So now I've given it a task and I've given it some context. So this would be something that you would definitely do in ChatGPT. Now it is going to generate a response for me. So this is actually pretty useful as a way to access this. Now, LM Studio is nice because you can actually have pretty decent prompt interactions with it. Where you don't have great interactions are when you're using Olama. Now, the other thing that you'll see here, and I'm not sure, well, it's coming up with my instructions. It's got I don't know if this is going to be any good, but it was able to do it. I can also go in here to my settings and I can enable this to operate with, see, I notice I have server port 1234. This means that I can write applications and use an open API, ChatGPT compatibles API, which is the chat completions API. And I can actually write an application. So I could write an application in Python using Llama Index, and I could create an entire workflow. And I don't actually have to use this LM Studio interface that I'm working in. So I could actually write this whole thing using API calls. So my recommendation, especially if your plan is to, work in the AI industry, to really get a good grip on local models, because using these local models is going to solve a problem for medium and large size companies. You can create, if there's nothing worse than going into a potential client saying, I have this great AI automation that I want to sell you. And then they come back with, well, we're not allowed to use cloud models here because we don't want anything about our company being sent to ChatGPT. So being able to do these projects with local models makes it worthwhile. Another thing is, especially if you're doing things with vector embeddings, tokens get really expensive really fast. So using these tools are really a good way to be able to build applications. And the working with local models and working with the DevOps and the MLOps part of it, it's definitely a decent career move. So this is the basics of the models. So I will take a couple questions because we have 10 seconds or 10 minutes left. I see Mohammed's got his hand raised. What's up, Mohammed?
Ed, amazing content. I learned a lot about local models. I actually so far have not yet dabbled with local models. As you already know, I am currently trying to vibe code the app for Big Bang Bot. But
Hmm.
my plan is, when the time is right, that I would like to revisit my legacy code for that I have implemented for the Interactive Brokers API, and I would like to also vibe code it. But I would like also to supplement it with the Interactive Brokers API documentation. And now I'm thinking if I maybe can scrape this API content from the web and give it to the local model in a supervised fine-tuning way, or should I just put it in some markdown files and give it as a RAG to a cloud model and vibe
So
code that?
yeah, so that's a good question. Now, the the reason, so if you could fit it all in a single markdown file, you would just include it in your prompt. So one of the things you actually have the ability to do in LM Studio is give it a system prompt. So I can come over here and I can actually put in LM Studio, I could put in that entire markdown file. So if you were able to get the documentation, then I would say go to something like Claude. Go to Claude and say, I want a markdown file that has all the documentation for take this documentation and make a very concise markdown file. Then from there, you can just paste that in as part of your system prompt, and then you don't actually have to do retrieval augmented generation. This is where it's a context augmented generation. You notice I'm on the context tab. You're basically augmenting the way the local model is operating by pasting in a piece of markdown file that's going to be used every time. So that's a really good use case for a local model where, let's just say you have a local model and all you want it to do is hold a bunch of documentation and have people be able to ask questions of the documentation. So that's actually something I would actually highly encourage
Mm.
doing with that type of documentation,
Mm.
especially if it's something like proprietary documentation. Now, you're talking about doing something that's actually published, but if I'm talking about an organization, and let's say I'm the HR department, and I want to have all of the payroll, um, for my company, I want to have all the payroll and benefits rules in one place if it fits. Now, the other thing you got to realize here is we have this issue with the size of the context window. So you do have to have room for both your markdown file and the questions that are going to be asked. So,
Right.
um,
Uh,
o-
Only one markdown file? Can I just maybe scrape it and put it in multiple markdown files and
well,
then
you
ask
can, but
questions
if you
about it?
put it in multiple markdown files, then you're going to need a mechanism to determine which markdown file to put in with each prompt.
Yeah.
So, easiest way to do it is to have a single markdown file that you always use. But
Is a
if
cloud
there's too
model.
much information, you then need to intercept the prompt, and or you would do it with an MCP tool, which would pretty much be the way. And when you're defining your MCP tool, you would say information about this is kept in this markdown file,
Yeah.
information about this is kept in this other markdown file, and that way the LLM determines which markdown file it's going to load based on the prompt that you
But you
put in.
said you need to go with a cloud model instead of doing a supervised fine tuning with this data.
If you can, I mean, again, it all depends on your use case and your cost, and your cloud model might get really expensive really fast if you've got a lot of users. So that you're always going to be trading off cost for a little bit of quality. I'm now to the point where
Sure.
I'm never going to say that a local model is going to be better than a cloud model. The cloud models are just too good. There's no way
Okay.
you're running Claude locally. But if you can't afford to run that many tokens through Claude, then you want to use a local model. So, Eben, Ray,
Thanks.
Yes, hi, thanks, Ed. Hey, I was wondering, as a part of developing these local models, if you want to also start working and learning about running your NCP server locally, as a part of the stack, and is that something to start thinking about as you're working with the local models? And does that mean you also then have to be able to program the tools into that NCP to work with, hugging or work
So
with
that's
JQ?
actually a good question. That's actually the topic of tomorrow morning's Pro Community vibe coding session. We are actually going to build a local MCP model. And you can basically take Claude code, and Claude is the best for this if you're vibe coding it because it was Anthropic that came up with MCP. So the easiest way to do this is to tell Claude that you want to build a local MCP server. It will build it for you. It uses a SDK called the MCP Python SDK, which was created by Anthropic. And I have actually created several local MCP servers without the slightest idea how they work. This is where I've actually gotten burned by vibe coding. I actually have some local MCP servers that call external APIs and call local things. I don't actually know how they work. Now, I do want to learn how to create MCP servers that local ones that can read and write to the file system, because
Right.
one of our goals is to write our own coding tool. And in order to do that, you need to be able to read and write to local files. So yes, that is actually writing your own local MCP servers, especially if you're running local models, is the next natural step after just getting the models to run. So
If right now I'm just working on testing a prototype for a product, and so as it scales up, if it's going to be, let's see, hardware technology that's going to use LLMs and artificial intelligence to support it, then it's something to maybe how large can you create an MCP? Can you create an MCP that's as large as a public, open model? Is
so
that
the
kind of
so the MCP itself is actually pretty small. Because the so see that's the thing is an MCP is of infinite size. Because what the MCP is doing itself is it could be calling a giant API, it could be going to a giant data warehouse. The MCP server itself is really just something called a model card and the functionality. So the what the MCP server is doing is it is telling the large language model that I'm available, these are the things I can do, and this is how you call me. And so it's basically the MCP server itself is actually the documentation of what you're going to do as part of the tool. So you could create an MCP server that goes against a multi-terabyte database in, let's say, Oracle or DB2 or something like that. But the model itself, you don't have to worry about the model get or the MCP server getting too big because you're going to actually it's going to go off and do its own thing either somewhere on the network or I have local servers, so I like to run things on my own servers. But the size of the MCP server itself is actually not um, the concern. Performance is the concern though, because you do need your MCP server has to come back with a response in a reasonable amount of time, or the LLM is going to give up on it. So
do
you
we have
can't go out
to
and do something that's a full table scan of a 6 million row table. Uh,
think about hardware when it comes to that?
Absolutely. Absolutely. You
Okay.
do. I mean, there's a MCP has its own architectural challenges, and so you just have to, work through to work through them. But they're not that heavy of a challenge, and you when you have Claude to help you, you can pretty much get through it. So yeah, that's the way to
Thank
go
you.
about it. All right,
Thank
hey
you so
Daryl.
much.
Hey Ed, thanks again for your sessions. They're awesome. So I'm a little fuzzy on how it goes from the prompt to the tool, and it's what I'm hearing is that the LLM is deciding to use a tool and which one. If you know better in your prompt, like through the system prompt, can you influence it to
Yes.
say
So
use this tool? Because it's to me, it's everything's so fuzzy. Like, yeah,
yeah, so one of the things you can do, so notice if you look down here at my screen, I have three tools installed. I only have this one except turned on. So one thing to do is turn off and on the MCP tools, but the other thing to do is actually in your prompt tell it what tools to use. So
okay,
what the LLM is trained to do is when it comes to the conclusion, either by you telling it, hey, we want you to use a tool, or go out to the web and look for this. It's then going to look and say, all right, what tools do I have access to? Then it's going to read the model card for each of those tools, and it's going to make the decision which of the tools it wants to call to get to the second part of the prompt.
right.
So
So
that
so
is
that makes sense.
why you need the reasoning models for the tool use because it's got to figure out a multi-step process. It's not a single shot prompting. It's saying, get me this information so I can do the thing I need to do.
Yeah, that makes sense because everything being fuzzy, it seems like I know what I want it to do, and I know we're not procedural in this world anymore, like I am in my current world. But being able to influence it to use a specific tool because I know it can do better using it. it's good to
Yes,
know
and
you
you
can do
can
that.
put that up here in this in the system prompt. You could say
Yeah,
you could give it like an order of priority. Check the Hugging Face MCP server first.
right.
If you cannot do what you need to do, use this server. You can definitely influence it, or you could just make it so that only those models or only those tools are turned on for use.
Thank you.
So, all right, John, how are you?
Hi Ed, thank you so much. This has always been a very wonderful experience. I'm just curious. I know you talked about Olama needing you to restart your PC, but I
Yes.
just want to know, have you had any experience with Open Web UI? And if you have,
Yes.
I'd just like to get feedback from you or something.
Yes, I have Open Web UI installed on this box, and I use it a lot for two things. One, if you really want that ChatGPT look and feel, Open Web UI is great. The other thing I like Open Web UI for is it has more, what's the right word? It has more API, different API calls. So with Olama itself, you only have the default API calls of OpenAI, whereas with Open Web UI, it has a whole set of other API calls, and it also has the Swagger documentation. And I don't know if you're familiar with Swagger, but Swagger makes it really easy to test API calls. And so I like using Open Web UI for that reason. But since I started using LM Studio, I have not thought about Open Web UI as much as I used to because, LM Studio really has the combination of running the model and having a pretty decent interface built into it. Um, there are also certain things about Open Web UI that I like and some that I don't. One thing that I don't really like is the fact that you have to create an account, and if you're calling the API, you actually have to create an auth token for a local LLM call, which I understand they're doing it to be compatible with the cloud models. But yeah, there's certain good things about it. I do highly recommend it if you're using Olama. If you're using LM Studio, it's not quite as necessary. Okay, Vortex Vision Marketing. I always love how these things show up on Zoom.
Thank you, Ed. Yeah, so I just had a question. The VP, if you're using a local model, could you run it on a VPS? And I know obviously privacy would be a major drawback for this.
There's no reason not to run it on like a virtual private server. You got to realize what is your hardware. Okay, a couple ways. You have to have access to GPU one way or the other. So if you are running like a virtual machine, I'm assuming that's what you mean by VPS. You need to have GPU access, either through the unified memory of the Mac or access through usually, like if you're using Proxmox to do virtual machines, you're using something like a PCI pass-through to make it work. But it's going to be trickier, and it isn't because you need like bare metal, where you need to actually get to the hardware itself. It's more that virtualizing GPUs is tricky. Did I answer your question? Because I'm not sure I actually understood it 100%.
I think maybe that's more geared towards virtual machines, which is
Yeah,
like, if you have the images and containers and so on.
yeah.
I think what I'm more referring to is like for example, there's like Hostinger, they have VPS servers that you could rent for a
Okay.
very cheap price per month, and then they provide you vCPUs and uh a lot of specs. You're just basically renting a private server, right?
Gotcha. That's going to be hard because those usually do not have GPU, and they usually don't have nearly as much memory as you're going to need to run a local model. Now,
Oh, and what about latency?
the the network latency isn't going to be as big of a deal because in the end, all you're doing in that case is The only thing that's coming over the wire is you're watching it do its work. So the latency isn't going to be as bad. I think it's going to be when you're using a virtual private server, the lack of GPU resources. So the one that I use a thing called InterServer. And the reason I use that is you can get bare metal Proxmox hosting, so you can actually host your own virtual private servers from a virtual private server or from a private server.
Yeah.
But I think for local models, the performance is going to be so bad without GPU. Now you can run Olama with CPU only, but I think I think the performance will kill you, and the need for that much RAM is going to kill you because you have to be able to fit all of the RAM in the memory.
Yes, yes.
So, um,
Okay.
all right. And
Thank you.
Vasco, did I? Yeah, you're next, or your hand is up. So
Yeah.
I'm
Hi, Ed.
getting to
Thanks so
you.
much for today. My question is, how unrealistic would it be to think of some sort of to add encryption to a communication with a cloud model?
Almost not at all. Because in the end, the cloud model has to get it in plain text. So you, by default, because ChatGPT is HTTPS and it's running over SSL,
Hmm.
you are encrypted point to point. You're encrypted in transit. So you don't have to worry about anybody stealing your prompts from your PC to the cloud model. You have to worry about the cloud model getting sued by the New York Times,
Yes.
and then the New York Times turning over your prompts to to the Southern District of New York. That's really more of the worry than the encryption when it comes to sending your data over. So, did I answer
So
your
unless you're
question?
speaking a language, well, but no, you couldn't because the LLM's trained in English. It has to be in English. Yeah, I don't know.
Well, actually, no. I mean, it depends. What's the Alibaba models. One of the newer ones is amazing that it speaks, I think, 157 languages. I
Okay.
mean, it definitely is not. There are multilingual and multimodal models. The one thing
Right.
it doesn't speak is encryption. So
Right.
you can't send it an encrypted, you can't send it an
Format.
encrypted prompt. Now, that is actually a really good idea, by the way.
Yeah, I
Um,
just had it. I was like, because that would
that,
solve a
that
huge problem.
now that I'm actually thinking about it, unfortunately, I don't have $1 billion to train my own foundational model,
Yeah,
but
exactly.
actually sending a private key, public key to a model, um, and then sending the prompts encrypted
Yep.
is actually a really, really good idea. And if Anthropic is listening, we want a commission. No,
We
that's
do.
actually a really that's actually a really good idea. I just don't think we could do it.
So what would you need to? You would need to train an LLM from scratch on a certain encryption layer, right? Or a encryption
Um,
language, right?
at some point, you the last step before you go to the model has to be decrypting what you sent to the model. The problem is, even if it's only a short wire from the time it's decrypted to the time it goes to the model, it's still interceptable
Yeah.
if you're a court. You would actually just need to build into the model itself a public-private key encryption algorithm that I could actually see how to do it. I just don't. It's the training the model from scratch. Maybe it's something you could supervise, fine-tune a local model to do it, but I think it would have to be done through the API. I mean, I see the value in it. I
Okay.
think somebody will eventually do it, but I don't think I'll be the one to do it because I think that there's some challenges to it that they're above my pay grade. So, but yeah,
Okay.
that still is a good idea for anybody who's listening. Um, Juma, how's it going?
What's going on? Uh, Talking about the system prompts, and let's say I'm connecting this to my application. Is there an automated way to like constantly feed it information? Like, is that through the MCP server? Like, if I had documentation that my app wanted to use, and just have that constantly getting updated and then pushed to the local model.
You, all right. So the thing is if you're going to push it to the local model, you have to have a capability to clear the local model. So, because think of it as being like a glass of water. When it fills up, it just spills over.
Right.
So and that's why when you're using Claude or you're using Gemini, you'll see it say it's compressing its context. So I actually had some really I had a pretty bad experience with this OSS until I increased the context window. So I was just putting too much in. So if you're talking about constantly pushing more and more data into the context window, you're going to want to clear the context window and then push new data in. So that's really where context engineering comes in because yes, you need to do it. That's exactly what Claude Code does. So when I'm working on multiple programs in Claude Code, it especially for Skillix, the code base is way too big to fit inside the context window of Claude Code. So Claude is constantly pushing stuff into the context window and pulling stuff out of the context window. The thing that I don't know how to do is pull the stuff out of the context window without clearing the entire thing. So yes, there's a use case for that. I just don't know exactly how to do it. So. All
Gotcha.
right. I want to thank everybody for showing up. A bunch of you I'll see tomorrow. I think a big chunk of you I'll see you tomorrow when we're going to try to build this MCP server from scratch. Hopefully, I will know exactly how to do it by then. But I want to thank everybody for showing up, and we will be in touch soon. Thank you all.
Thank
Thank you.
you.
Yep.
Take care.
Thanks.